Alright, so up until now my origin has been the center. Now the center has moved to this point, and it's actually always going to be labeled as h comma k. So that's always going to be the center of our circle. And we're going to see how this relates to the distance formula using any point on that circle, which we're going to just generally label as the x and the y. So I want to think about this right triangle again. And it's basically related to the Pythagorean theorem or the distance formula. I'm going to just remind you of the distance formula here. It's the square root of the difference between the x's squared plus the difference between the y's squared, which is basically just a different way to find the a and the b in that right triangle. If I think about that as a, b, and c using Pythagorean theorem, this is just an easy shortcut way to find it on a coordinate plane. And that's really all we're using. I'm thinking about the difference between the x coordinates here, between that point and that point. So I'm using x as my x2 there, and then the h as the x coordinate of the center. That's my x1. I'm going to do the exact same thing for the y's. My y minus the y coordinate of the center. And I'm really just plugging into that equation, although I'm going to rearrange that a little bit. I'm going to square both sides of that, because this is the general form of our circle. I'm going to square that just to get rid of the square root. I'm going to square the other side. So this stands for the distance, which in this case is really just the radius. So this equals the radius squared. So I'm just plugging into that distance formula using these 2 points. An easy, really easy way to see this is thinking about how I would find this side and this side using that. It's basically just saying that y minus k, the y value here of 5 minus the y value here of 2, would tell me that length is 3. Same exact thing for this bottom side. X minus h. The x value at that spot is 5. The x value at the center is 2. So that would tell us that 5 minus 2 is 3. So we're just finding those two sides in that right triangle, and basically thinking about a squared plus b squared equals c squared, where c just happens to be the radius. And that's going to work on every point in this circle. That is the standard form for any circle. It's essentially just Pythagorean theorem, where that c is the radius, the a and the b are just coming from the difference between my x value in any point along the circle and the x value in that actual center, and the y, any point on the circle, and the y coordinate from that center. So these are directly related to the distance formula, where this radius has to be the c in that right triangle that I set up. So I'm looking to find the equation of that circle. So I know the center. My h is 2, my k is 3, and my radius, I also know, is 5. So I'm just going to reference the general form of that equation first. X minus h squared plus y minus k squared equals the radius squared. Honestly, for this one, it's just plugging those 3 numbers in. It's just taking those 3 and plugging them into the right spots. X minus 2 squared plus y minus 3 squared equals 5 squared. Now, I want you to simplify this part, but you don't actually need to FOIL these out. In general, this is actually how it's going to look. I'm going to square 5 and change that into 25. But that is the standard form of the equation for that circle. Sometimes you will see these FOILed out, but for right now, we don't need to worry about that. That's as simple as that needs to get. The center is represented directly by those coordinates there, whereas the radius is represented as a squared number there.